Now we come to the session 42, the trapezoidal rule. So already know the theorems and the trapezoidal formula. Then again and derive the theorems and come to the some few problems. We come to the some few problems. See the trapezoidal rule by using Newton's forward interpolations formula. So you are finding y naught plus delta yn, y naught plus p into p minus 1 by 2 factorial del square y naught plus p into p minus 1 p minus 2 divided by 3 factorial del square y naught, etc. Now putting n equal to 1 there, so put also p equal to x minus x naught by h, also we cross multiply, so x equal to x naught plus ph. So you are simplifying all these terms, put n equal to n, h equal to n, we get so the interval. Then use then put n equal to 1 in the general quadrature formula. In the previous slide we get a formula, the replace put n equal to 1. So this is the way in general quadrature formula 3, then all the difference except the first order differences delta y naught will become 0. So the interval I1 should be equal to integral of x naught to x plus h f of x dx equal to h of y naught plus 1 by 2 delta y naught equal to c h of y naught plus 1 by 2. What's the delta y naught? So y1 minus y naught. So again simplify h by 2. So y naught. So 1 by 2 is there. If you take 1 by h outside, so we get y naught plus y1. So again we come to the second, the term I2 equal to integral 1 from x naught plus 2h, integral 1 from x naught plus 2h. So f of x dx. So we get f of x dx. Replace. So again we get h by 2 y1 plus y2. So again we go for in the way the integral of in the third integral I3 become integral of x naught plus 2h to x naught plus 3h. So again we get simplifying, we get 1 h by 2 y2 plus y3. So on. So in the general in should be equal to integral of x naught integral from x naught plus n minus 1 times of h to x naught plus nh f of x dx is equal to h by 2 yn minus 1 plus yn. So this is we adding all these terms. So that is integral of run from x naught to x naught plus nh f of x dx should be equal to h by 2 y naught plus y1 h by 2 y1 plus y2 plus etc h by 2 yn minus 1 plus yn. So we take h by 2 as entirely common. The first and last term, only one term appear. So y naught plus y1 plus y2. So y1 2 times of y1, 2 times of y2, 2 times of y3. If we add all this thing, we take a 2 outside. So 2 times of y1 plus y2 plus y3 etc yn minus 1. So generally we get the trapezoidal rule say the integral of x naught to integral from x naught to xn plus x naught plus nh f of x dx should be equal to h by 2 y naught plus yn plus 2 times of y1 plus y2 plus etc yn minus 1. See here the values, the interval just for the interval differences is 1. The constitutive difference is just 1, x naught to x naught plus nh, x naught to x naught plus h. So n is 1. So this the difference. So we get one formula. This is that is called a trapezoidal rule. So similarly, if we come to that, if we take some problems, find evaluate integral from 0 to 6 dx by 1 plus x square by using a trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, Weddell rule compared to result with its actual values. See, all the method formula we know, all the way we are finding all the formula by quadrature formula. For n equal to 1 we get a trapezoidal rule, n equal to 2 we get Simpson 1/3 rule, if n equal to 2 we get 3 by 8th rule. Then we take long difference 6, we get a vital rules. So in the trapezoidal rule we have, so in the formula we get, so is I2 we get like this form I1 plus y1 I1 plus, this is theta y1 plus y2 like that. So if we take substitute these values, the divide the interval should be, see this is interval should be 0 to 6. So divide the interval into 6 part. So the width should be equal to 1. The equal interval width should be equal to 1. The values of f of x equal to 1 by 1 plus x square are given below. So take values. So x should be first, width should be 1, 0, 1, 2, 3, 4, 5, 6. So this is the way the corresponding values of f of x. If x equal to 0, so 1 divided by 1 plus 0, suddenly we get 1. If x equal to 1, so 1 divided by 1 plus, and if 1, we get 1 divided by 2, we get 0.5. So if x equal to 1, 1 divided by 2, 1 divided by 3 is like this. So 1 divided by 5. So we got x equal to 2, we get 1 by 2 square plus 1, suddenly 1 by 5. Suddenly, if x equal to, corresponding values of f of x is 0.2. If x equal to 3, corresponding values should be equal to 0.1. If x equal to 4, corresponding values should be equal to 0.0588. So if x equal to 5, the corresponding value should be equal to 0.0385. If x equal to 6, the corresponding value should be 0.027. This is so the first interval is called, this is x ranges. The corresponding ranges should be like, we call this should be called y0, y1, y2, y3, y4, y5, y6. Now you take a trapezoidal rules. What's the formula says? Integral 1 from 0 to 6 dx divided by 1 plus x square is equal to h by 2 of y0 plus y6, because that last interval should be 6. So y0 plus y6 plus 2 times of y1 plus y2 plus y3 plus y4 plus y5. So substituting 1 by 2, y0 here 1 plus y6 is 0.027. So plus 2 times of y1 0.5 plus y2 is 0.2. So like that, I'm substituting all the value. So we get 1.4108. This is the value of integral of 0 to 6 dx divided by 1 plus x square is 1.4108 in the way of trapezoidal rule. We come to the Simpson rule in the same way in the calc. Suppose if we come to the Simpson 1/3 rule, 3 by 8th rule, and middle formula, we first derive the formula, then substituting the value we get. Again, if we take one more problem in problems, so integral from 4 to 5.2 log x dx using trapezoidal rule. So again, take x, the values given. So x is given for the corresponding values of log x is 1.38629. If x equal to 4.2, corresponding values of log x is 1.43508. If x equal to 4.4, the corresponding values of log x is 1.48160. The x is 4.6, the corresponding values of log x is 1.52605. If x is 4.8, the corresponding values of log x is 1.56861. If x is 5, the corresponding value should be equal to 1.60943. If x is 5.2, the corresponding values of log x is 1.64865. See, you have observed this, the interval differences 0.4, 4.2, 4.4, 4.6, 4.8, 5, 5.2. These intervals should be like this. You are dividing the intervals should be the equal interval. The interval would be, the difference of the intervals should be 0.2. So trapezoidal rules, there are 6 divisions. 1, 2, 3, 4, 5, 6, 6. So each interval should be equal to 0.2. So suddenly integral from 4 to 5.2 log x dx should be equal to h by 2 of y0 plus y6 plus 2 times of y1 plus y2 plus y3 plus y4 plus y5. Now substituting, so in each interval difference is 0.2. So 0.2 divided by 2 of y0 is 1.38629 plus y6 is 1.64865 as 2 times of y1 is 1.43508 plus y2 is 1.48160 plus y3 is 1.52605 plus y4 is 1.56861 plus y5 is 1.60943. Now substituting, we are calculating 0.4. This is the value. So totally we get integral 1 from 4 to 5.2 log x should be equal to 1.82765. So this is that we are finding the trapezoidal rule, the log x. So similarly, one marvel, if we take exponential formula, evaluate integral 1 from 0 to 1 e power x dx approximately in step 0.2 by using trapezoidal rule. See, is given the functions. What's given functions? So I take all this f of x, y equal to f of x e power x. So this is the way is take the step 0.2 differences. So h should be 0.2. So by we use a convenient interval should be a minimum should be a 5 or 6 way. So x is 0, 0.2, 0.4, 0.6, 0.8, 1. So 1, 2, 3, 4, 5, 6 similarly. If x equal to 0, corresponding values of f of x or yx would be 1. If x equal to 0.2, the corresponding values of x is 1.2114. If x is 0.4, the corresponding values of f of x is 1.4918. If x is 0.6, the corresponding values of f of x is 1.8221. If x is 0.8, the corresponding values of f of x is 2.2255. If x is 1, the e power, so corresponding values of f of x is 2.7183. So come to the problem formula. The trapezoid integral 1 from 0 to 1 e power x dx h by 2 y0 plus y5 plus 2 times of y1 plus y2 plus y3 plus y4. So substituting all the values, h equal to the intervals should be equal to 0.2 divided h is 0.2. So h substituting 0.2 divided by 2 of y0 is 1 or y5 is 2.7183. So simplifying, plus 2 times of y1 is 1.2114 plus y2 is 1.4918 plus y3 is 1.8221 plus y4 is 2.2255. So simplifying, so suddenly we get the integral of 0 to 1 e power x dx is 1.72192. The interval should be like. So this is the value of by using the trapezoidal rule to find the values of e power x. This is the